Okay, these are the graphs of the trig function. All right, this is the graph of the sine curve. I realize it's hard to see, but you know the sine curve goes like this. I just finished talking about functions and one-to-one functions. All right, this is clearly a function. It passes your vertical line test. But does it does it pass your horizontal line test? No, it does not. Which means it's technically not a one-to-one function. Neither is the cosine, neither is the tangent, neither are any of these other functions. They are functions, but they're not one-to-one. But we need them to be one-to-one functions. We need to look at these as inverses. So what they did is they took each of these functions and they restricted the domain of these functions so that they are one-to-one. They just take a piece of it. Now for the sine curve, here's what they did, and I don't know who they are, but they did this a long time ago, okay? They decided that the piece of the curve you're going to look at on the sine to make it one-to-one is this little piece that I just colored blue. It is the piece of the sine curve that goes from negative pi over 2 to positive pi over 2. Which means only that piece has an inverse. And if this piece has an inverse, it is going to be the inverse sine of x with a little -1, or it is going to be called the arc sine of x. And any angle that you look for is going to have to be between negative pi over 2 and positive pi over 2. Now let me try to explain to you what that means. If you see this notation, y is equal to the inverse sine of x, or y is equal to arc sine of x, they are asking you to find y, an angle that's between negative pi over 2 and positive pi over 2, whose sine is x. So if I look at this right here, this says find an angle y in between negative pi over 2 and positive pi over 2, whose sine is the square root of 3 over 2. All right, now let me ask you something. If you are looking between negative pi over 2 and positive pi over 2, remember this is 0, this is pi over 2, down here is negative pi over 2. So you are either looking for an angle that's rotated up here or an angle that is rotated down this way. Which means you are looking for an angle that is either in quadrant 1, in which case that would be a positive angle, or you are looking for an angle in quadrant 4 that's rotated down. It would be a negative angle. So your angle has got to either be in quadrant 1 or quadrant 4. If it is in quadrant 1, it's positive. If it is in quadrant 4, it has to be negative because it's rotating down. All right, now, so how does that apply to these? You're looking for the angle y that has got a sine of the square root of 3 over 2, and it's got to be either in quadrant 1 or quadrant 4. So I want you just to think about this. If you do a smart trig class, the sine of the angle is square root of 3 over 2, which is positive. Is the sine value positive in quadrant 1 or quadrant 4? Well, it's positive in quadrant 1. So this angle y that we're looking for is in quadrant 1 because it's positive, and it's got to be equal to the square root of 3 over 2. So all you have to do is look down your exact value sheet in quadrant 1, and you know that's right here, and find an angle in here that's got a value of the square root of 3 over 2. There it is right there. Look across at your exact value sheet, and the answer is pi over 3. So our answer is y is pi over 3. That is the angle in quadrant 1 that has a value square root of 3 over 2. There's one answer only because these are functions. So it doesn't matter. You could keep looking down here and find another one that's a 1. In fact, find square root of 3 over 2. There's square root of 3 over 2 right there. But that is not in the correct quadrant. So you can't use that one. All right, think about this one. I need the angle here in quadrant 1 or 4 that's got a sine of negative 1/2. Well, negative 1/2. That's in quadrant 4, right? So my answer has got to be in quadrant 4. And I told you up here, if your angle is in quadrant 4, it has to be a negative angle because it is rotated down. So all you have to do is look at your exact value sheet in quadrant 1. There's my 1/2. The angle is going to be pi over 6, but it's going to be rotated down. So the answer is negative pi over 6. So y is negative pi over 6 because this is negative and this has got to be in quadrant 4. Are y'all sort of kind of following what I'm saying? All right, look at this one. They're looking for the angle in quadrant 1 or 4 that's got a sine of the square root of 2. Well, if I look down here in quadrant 1 for the square root of 2, there is none. So the answer is it does not exist. There is none. There is not one. All right, suppose I ask you this. The angle whose sine is, let's see, negative square root of 2 over 2. This is a negative value. I'm looking for an angle. This time it has to be in quadrant 4. So the angle has got to be negative pi over 4. Yes. That's all you're doing. Looking for the number they give you, and that's it. You're done. Okay. Well, that's fine and dandy for the sine, but they had to take the cosine, and they had to do a different restriction on this one. If you'll look at the cosine function, if they did it the same way as the sine, this piece is not 1-to-1, so they couldn't restrict it the same. So they decided for the cosine function to look only at this little piece, which is the piece between 0 and pi this time. And that piece has got an inverse. It is called the arc cosine of x, left off the c, or you can write it as cosine with a negative 1. That is your notation for the inverse cosine. These angles between 0 and pi, this is 0, this is pi over 2, this is pi. That means your angle is either going to be in quadrant 1 or quadrant 2, and they are always positive here. This is going to be an angle in quadrant 1 or quadrant 2. Your angles are always positive because you're rotating a positive direction. So that's what we're doing for the cosine, the arc cosine. Okay, so you may want to fill this in. The domain of the arc cosine is between negative 1 and positive 1, and the angle you're looking for is between 0 and pi. It will either be in quadrant 1 or quadrant 2 to go from 0 to pi. So looking at a couple of examples they have on this sheet. Finding the inverse cosine value. Y is equal to arc cosine of 0. They are saying find the angle in quadrant 1 or 2 whose cosine is 0. So you look again on your exact value sheet in your cosine column. You look down until you find a 0. The angle that has a cosine of 0 is pi over 2. So the answer would be theta, or y, is pi over 2. For this one, the angle whose cosine is 1/2. Well, you look, cosine column, cosine of 1/2, the angle is pi over 3. Now for this column, since you can look from 0 to pi, you may want to put a line down here to tell you to stop right there, because you can look all the way down here from 0 to pi when you're looking for cosine. Let me give you another example. What if it's negative? I don't know why they didn't put a negative one on here. What angle has got a cosine of negative square root of 2 over 2? Remember, it's always got to be positive, and you can look in this whole thing. So right here is negative square root of 2 over 2. So the answer here is 3 pi over 4. Because we can look all the way down here. So our answer is 3 pi over 4. Are y'all following? Y is equal to arc cosine of negative 1. Can y'all tell me what that is? What is the angle that's got a cosine equal to negative 1? That would be pi. Or is there a question about cosine? Arc cosine. With me? Okay, for tangent, and I'll show you on the graph. You know, the tangent, again, is not a one-to-one function, but they took only one piece of this tangent function. They took this piece right here. They ignored the rest of it. So the only piece they looked at is between negative pi over 2 and positive pi over 2. That piece has got an inverse, and the inverse is the arc tan of x. So between negative pi over 2 and positive pi over 2. So again, positive pi over 2 comes up down here. Negative pi over 2 comes down like this. So that is quadrant 1 or quadrant 4. If it is in quadrant 4, it's just like the sign, it is negative. So, if you want to write these on your notes, the domain of the arc tangent is negative infinity to positive infinity. And the range of the arc tan is negative pi over 2 to positive pi over 2. It has parentheses here because they're asymptotes on the others. All right, so now that means when we're looking at our exact value sheet here, on the tangent, we're going to have to look just like we did for the sine. We can only look down this far. If the value is negative, you put it in quadrant 4 by making these angles negative. So, back over here. This is asking for the angle who's got a tangent of the square root of 3. So is there an angle that's got a tangent of square root of 3? And it's got to be in quadrant 1 or 4? Pi over 3. All right, if it said the angle whose tangent is negative square root of 3, what would that answer have been? Negative pi over 3. All it does is change your rotation down to quadrant 4. So it would be negative pi over 3. All right, what about this one? The angle whose tangent is negative 1. What do y'all think? Negative pi over 4. Negative pi over 4. Yeah, I'm sorry, I changed the worksheet, obviously, and added this one. All right, what if I have the angle whose tangent is angle whose tangent is square root of 3 over 3 would be pi over 6. Okay. Question?
I have one cosecant. How would you solve that?
Okay. All right. Let's get to those. Let's get. We're going to get to here. Here we are right here. Okay. Now, the reciprocal of these functions, they have taken and they've restricted them also. So let me show you how they restricted those. And you asked for cosecant, so let's talk about that one first. All right, the cosecant is the reciprocal of the sine. So they restricted the cosecant just like they did the sine. It is restricted to be between negative pi over 2 and positive pi over 2. which means it's got to be in quadrant 1 or quadrant 4, just like its reciprocal. So when you're looking in your cosecant, you're only going to look right there. And if it's negative, you're going to flip it to quadrant 4. Okay? So just like its reciprocal. Now, the secant, they restricted the secant just like its reciprocal. The reciprocal of this one is the cosine. It's restricted just like cosine to be between 0 and pi, which puts it in quadrant 1 or 2. And if you're looking on this sheet right here, you're going to look all the way down. This has got your positive and your negative values right here. So you're going to have all positive angles for the secant. All right, so far the reciprocals have been the same. But guess what? Tangent and cotangent are not restricted the same. All right, tangent went from negative pi over 2 to positive pi over 2, but cotangent is going to go from 0 to pi. So it is in quadrant 1 or quadrant 2. So for cotangent, you can only look, cotangent, you look all the way down here, 0 to pi. Okay? So, all right, I filled in part of this chart for you. These are the intervals, the quadrants of the circle. All right, arc sine is between negative pi over 2 and positive pi over 2, which is in quadrant 1 or 4. And its reciprocal down here is restricted just the same. It is in quadrant 1 or quadrant 4. All right, for the cosine, they restricted it to 0 to pi, which means it's in quadrant 1 or quadrant 2. Now you need to note there are no negative angle answers here. For a cosine. There will be no negative angle answers because you're staying in the positive rotation, quadrant 1 or 2. And for the arc secant, it is the same. You are in quadrant 1 or quadrant 2. Again, you're not going to have negative answers here. No negative angles. Now for the arctan, it's between negative pi over 2 and positive pi over 2, so it is going to be in quadrant 1 or quadrant 4, which means you can have negative answers. But its reciprocal, the arc cotangent, is between 0 and pi. It is quadrant 1 or quadrant 2, and again, there are no negative answers here. Questions so far? I'm going to get back to your answer. I'm going to work some problems for you just a second. Let you get all this written down. Let me know when I can flip it. I agree this can be kind of confusing, knowing where to look for your answers, how not to use a calculator, because this says don't use a calculator, so we're trying to do it without the calculator. Still writing, Kyle? Okay. All right, here are some other problems, and then I'll just pull some others out of the book. Oops, sorry. All right, they want degree measure here, so let's give them degree answer with the same type problems. Theta is the angle whose tangent is the square root of 3. So you're looking for the angle whose tangent is the square root of 3. They want degrees. So this time theta is 60 degrees. All right, here's an arc cosecant one you were asking for. Theta is asking for the angle whose cosecant is negative square root of 2. So for negative square root of 2, that's cosecant. All right, we can only look to right here. But this answer's either got to be in quadrant 1 or 4. So this one would have to be negative 45 degrees. because it's a negative value. They asked for degree measure, so that's why I did the 45 degrees. All right, let me. Did it? So they asked for it. You're
just sneaks it in, you don't realize it.
Don't realize they switched your y'all be careful of that kind of test time. All right, now here, I'm gonna pull some out of the book, and y'all just see if you can answer them by looking at your table. The angle whose cotangent is -1. Can y'all tell me the angle whose cotangent is -1? Angle whose cotangent is -1?
-45.
All right, look back carefully at your chart.
Ooh.
Ooh.
135.
What is it?
135.
Right. 135 degrees, right? Because you have to look down cotangent to the -1, and it would be 135 degrees. All right, in quadrant 1 or 2. Let's see. You can give me radian measure here. Arc secant 2 square roots of 3 over 3. So the angle whose secant is 2 square roots of 3 over 3. 5 or 6. Right. 5 or 6. Everybody okay with that? Angle whose cosine is -1/2. Okay. It's 120 degrees, or if they ask for radians, you would tell them 2 pi over 3. What else do I need to know? What about this one's in the book? Y is equal to arc cosecant -1/2. The angle whose cosecant is -1/2. Is it even in there? It doesn't exist. Yeah, it doesn't exist. If it's not on there, just it doesn't exist. All right, now you've worked some of your homework. Is there a question about any of these so far? Okay, just make a little more sense.
I remember being able to, I wasn't looking at the arrangement, being able to put it down to the, where it would say -1 instead of like thinking tangent, instead of saying -45, sure it was saying 145, 135 degrees. I thought it accepted the answer. I thought I remember that, but I thought it.
It better not have. Yeah, better not have. It better not have, because it says it only accepts the correct quadrant. Okay. All right, any questions about doing it off the sheet? Okay, it's for applications in the higher level math. We need to be able to find an angle. If they were working an application problem and they say, okay, I found that the value of this angle is negative something or other, then they need to be able to go backwards and find out the angle, with their given information, and they need to know whether it's positive or negative and how much rotation it is. So it's more for applications, but the reason we have to restrict it to those quadrants is so you have a function. We need an inverse function. And if you don't get it right now, just memorize it. That's my best advice. Okay, I understand your confusion. I said I understand the confusion. Alrighty now. The ones that are not done on a calculator are going to be done by this exact value sheet. Now there are some that can be done using a calculator to type these in. Now, the inverse trig function we have used on our calculators before. It is the same thing that it's always been. It's that second sine, second cosine, or second tangent button. So if it says use a calculator, you can use a calculator. And the good thing is your calculator knows the restrictions on every one except the cotangent. It does not know how to restrict the cotangent. but everything else is fine. If you wanted to find, and let me write some problems down before we get to these right here. If you wanted to find in degrees, it says, theta is the arc sine of 0.779000016. To put this in your calculator, it is that second sine button. So second sine 0.177900016 would give you theta. So check the mode on your calculator, make sure you are in degree mode, and then all you have to do is type it in, second sine 0.177900016, and the angle would be, if I type that in correctly, 10.247465551 degrees. Did y'all get my same answer? No?
No, on the first one you put 177 and
Oh, I added a 1, didn't I? I wonder why I did that. How about if I erase that? I'm getting a little creative. How about if I try that again? Ooh, big difference. How about 51? 169121193, and we are in degrees, so do not forget your degree symbol. I apologize for putting that 1 in there. I don't know what I was doing. All right, do you know what to do with this one? Again, in degrees. Negative point. This one's got a 1 in it. 133488816. So that would go in as second cosine, negative point. Did y'all get that? 97?
it has to be in degree mode.
Yes. If it says degree, you put degree mode. In degrees. Alright, but what if the function is not on the front of your calculator? What if it is like an arc cosecant? 1.9422833. When your function is not on the front of your calculator, if you can remember back when we typed this in before, it's going to be typed in the exact same way. We typed it in as, all right, the 1 divided by goes in the parentheses. So it would be second sine, the second sine, and then 1 divided by all that stuff like there. And you could get it all at one time. So second sine 1 divided by. And I got 30.9879.607 degrees. Okay, y'all with me? Now, your calculator knows everything except this one. If you are doing an arc cotangent, what you need to remember is that you can never get a negative number, a negative angle for an arc cotangent. It can't have a negative angle answer. So, if it gives you a negative angle answer, you are going to have to add 180 degrees or pi to your answer to get it back to the correct quadrant. This is only for arc cotangent. Your calculator knows everything else, and only if it's negative. So if we were putting this one in our calculator, theta is arc cotangent. It says degree measure. So to type that one in, it's secant tangent, 1 divided by negative 0.2528. Put it all over here. Secant tangent, 1 divided by. I got a negative answer. A negative angle is going to be down in quadrant 4. That is the wrong quadrant. So add 180 degrees to your answer, and the answer should be 104 point whatever degrees, assuming I typed it in right. So my answer would be because you cannot have an answer in quadrant 4. Yes, if you're in degree. If you're in radian measure, add pi. And only for the arc cotangent. Okay? What would we do for this secant one, this arc secant? This says put it in radians. So now you've got to change the mode on your calculator to radian mode. Change the mode. And then if you want to know the angle that's got a secant of -4, that's secant cosine 1 divided by -4. And the answer would be 1.8. And that is radian, so do not put a degree symbol on there. You are in radian measure. All right. I'm going to put a few more of these problems up here. Let's look at the book and see if I need to work some more of these. Okay, here are some problems from the book, right here. Do you have a question about how any of these would be worked? These are all calculator problems. Use the calculator to give real number values. Right? Assuming it didn't have that and that you didn't read that. Real number values, anytime you see those words, that is your key to change your calculator to radian mode. From here on out, you've got to be sure you know what mode you're in because you're going to be going back and forth. So real number value is always radians. So know whether you're in degree mode or radian mode. Do we need to do any of these at all? I think we do. I think we need to do number 66. I'm going to flip this over for just a second. All right, number 66 says, oops, y is, and this is in real number mode, says find the real number value, -36.874610, and it wants a real number. So what does that say about your mode? Radian mode. Make sure you're in radian mode. And type that in. I got that answer right there when I typed that in. Did y'all get something like that? No?
Did you forget the one?
What did I forget?
Is that or just keep going?
That arrow's supposed to mean it keeps going. Yeah, I got it. 3, 8, 4, 6, 1, 0. Did I type it right? Wrong.
Yeah, right.
Okay.
Let's get to the 700.
Okay, yeah. All right, but, exactly. This is not the correct answer because I've got to add pi, so just hit plus pi, and your correct answer is 3.114480368, and you are in radians, so do not put a degree symbol. Do I need to work another one of these types? Y'all got that? All right, they put an extra reminder at the top of this page right here. Be careful when using your calculator to evaluate the inverse cotangent of a negative quantity. To do this, enter the inverse tangent of the reciprocal, that second tangent, of the negative quantity, which gives you an angle in quadrant 4. Since the inverse cotangent is negative in quadrant 2, adjust your calculator answer by either adding 180 or pi to your answer. So this is just your extra caution. Don't give yourself a negative answer for inverse cotangent. Okay, and last but not least, we have these last couple problems. And these are done without a calculator. They're done by hand. And I put these in at the request of the calculus teachers because when you get to calculus, you need to be able to do this. But these are really quite easy. They want to know the cosine of the angle whose sine is 2/3. Well, all you do is start right here. And they don't want to know the angle. They just want to know what the cosine of the angle is. So all you have to do is draw a triangle. This is telling you that there is an angle out there somewhere. I'll just call it theta. And the sine of this angle is 2/3. So remember, Oscar had a heap of apples. The sine of this angle is 2/3. So back to this triangle. If I want to know the cosine of this angle theta, then all I have to do is find my missing side, and I know the cosine. So to use your Pythagorean theorem, this is 9 is equal to 4 plus x squared. So 5 is equal to x squared. So x is equal to the square root of 5. And so now all we have to do is find the cosine of this angle. The cosine of this angle is square root of 5/3. And that's all there is to it. Draw your triangle and find the value. Let's look at number B. They want the secant of the angle whose cotangent is -15/8. Alrighty, now think about this. If your cotangent, if there's an angle that's got a cotangent of -15/8, your angle's got to be in quadrant 1 or 2. Well, if it's negative, it's in 2. Here's your angle. One of these numbers is 15, one of these sides is 15, one of these sides is 8, and one of these is negative. The 15 goes on this side, the 8 goes over there. What am I doing? I don't know what I'm doing. How about 15/8? That'd be better. One of these is negative. Which one's negative? The 15. Use your Pythagorean theorem to find your hypotenuse, and I think it's something like 17 maybe. Square root of 289, isn't that 17? So my hypotenuse is 17. So now all we have to do is find the secant of this angle. The secant of this angle, that's the that's the reciprocal of the cosine. So the cosine is this over this, so the secant is 17/15. What? Are there any questions? Do I need to pull another